Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 3.2.1. Starting off with the M&Ms, which I tell you everything you need to have for a complete graph. And actually, this is worded a little bit differently than what I have mentioned. A few things that I've told you is you want to make sure that you have your X and your Y axis properly labeled. And I think most of you understand that the vertical axis is always going to be the Y and the horizontal axis is always going to be the X. In circumstances where you're dealing with different variables, maybe you choose T to be the variable for time and D would be for like the number of dollars. You'd want to label those, and you want to make sure that you put the D here and the T there, because it's not going to be obvious to someone looking at your graph why you put the numbers where you put them. So label your graph. Also, I would say you want to make sure that you make sure your graph is properly scaled and numbered. So I want to know what the counting sequence is. So are you counting by ones? Are you counting by twos? Are you counting by tens? Maybe you're counting by ones on the x-axis and counting by 20s on the y-axis. Make sure that gets labeled. I've also stated that when you are plotting points, you want to plot at least 3 of the points from your table into your graph, and you want to make sure that you label them. So 3 is the minimum, 4 would be even better. And when you're labeling them, make sure that you label at least 3 of them. All right, so for the following equation, solve for x. Make sure that you check your answer. All right, so solving for x, we're just doing the legal moves here. So 3x plus 7 is equal to negative x minus 1. I would add an x to each side, then take away 7. And then at the end, you've got 4x's is equal to negative 8. That means that x must be negative 2, since 4 times negative 2 is equal to negative 8. To check that, you plug in the negative 2 here and the negative 2 here, and by the time you work through all that, it should give you a true statement saying that the expression on the left is indeed equal to the expression on the right when x is equal to negative 2. So let's go ahead and take a look at these answers. Oh, did I not write them up top? I guess I just have them at the bottom. So for B, our solution was 1. And for C, the solution ends up being what? What is it that they're asking for? Oh, we're not finding a solution, because that would be all numbers would work there. It says use a diagram of an equation mat or some other method to explain why the opposite of x minus 3 is equal to the opposite of x plus 3. And I guess I just decided to show that that would be distributive property, right? Take the opposite of everything on the inside and it becomes negative x plus 3. Just like this is negative x plus 3. For each equation, a possible solution is given. Check to see if it is correct. So how do we check the solution? Well, if x is indeed equal to negative 4, then we should be able to plug it in here, and it should work out. So 3 times negative 4 is negative 12. Negative 12 plus 7 is negative 5. And on this side, negative 4 minus 1 is the same as negative 4 plus a negative 1, which is negative 5. So yes, they are equal to each other. That means that the answer is yes. Go ahead and take a look at these other answers. For B, the answer was no, because when x was equal to 3, sides did not equal each other. For C, the answer is no, because when x was equal to 2, you had 8 on the left and 0 on the right. They are not equal to each other, so that can't be the solution. And for D, when x was equal to 3, you plug the number in for x, and by the time you simplified each expression, both sides balanced. Negative 2 is equal to negative 2, which means that x equaling 3 is a solution for this particular equation. Now, I guess the question is, could there have been? No, there wasn't multiple solutions, just the one solution. For the rule y is equal to negative 2x plus 1, calculate the y values that complete the table below. Okay, so you can show your work on the side, or a lot of times you could just do some mental math. I generally start here at 0, and I'll plug in 1, 2, and 3, and then I'll look for a pattern. So 0 times negative 2 is 0, and 0 plus 1 is 1. 0 times, or 1 times negative 2 is negative 2, and negative 2 plus 1 is negative 1. And then we put in the 2 there, that becomes 2 times -2 is -4 plus 1 is -3. And you can see that there's a counting sequence, right? So we want to look for the pattern. What are we counting by? Looks like it goes down by 2 every single time, which means when you go in this direction, it's going to add by 2 every single time. So we were able to do 3 different calculations that were relatively easy, identify a pattern, and use that pattern to fill in the remainder of the table. So every single one of these is considered an ordered pair that can be graphed on a coordinate grid. So it looks like we need our coordinate grid to go to -4 and +4 for x, and all the way up to 9 for y and -7 for y. So, I mean, I could fit 1, 2, 3, 4, 5 different points inside this graph. So you don't necessarily have to go all the way up to where y is equal to 9 or 10. Just plot, as long as you can plot 3 or 4 points in your coordinate grid, that's all it has to be. So I counted by 1 on both my x and my y axis. I've got it labeled. And now I've plotted 1, 2, 3, 4, 5 points, and I've labeled 1, 2, 3 of them. This is a complete graph. So describe the resulting graph. What does it look like? Well, first of all, it's straight, which tells you there's a constant growth rate. But in this case, it's not really growth. It's decline, right? It goes down by 2 every time x increases by 1. And anything else? I guess that's a negative slope when it goes in this direction. I'm not sure if we've talked about positive and negative slopes yet, but if we haven't, then there you go. There's an introduction to the idea of a negative slope. And then simplify each expression below. Remember, we're combining like terms when we simplify expressions, and every one of these expressions except for D has a situation where you've got a minus sign in front of parentheses, which means you need to take the opposite of everything inside that parentheses before you can combine like terms. So if I take 4x plus 7 plus 3y, those are all fine how they are, but these guys have to change their opposite. So it becomes -1, minus 3y, and minus 2x. And if you want to change that to plus a -1, plus a -3y, and plus a -2x, you can do that as well. So let's just highlight all the like terms. And these can be combined. So the 4x take away 2 x's gives you 2 x's. The 7 take away 1 gives you 6. And 3y's minus 3y's, they form 0 pairs. They cancel each other out completely. Okay? So in every one of these instances, you've got to make sure that you take care of the dive bombers, send in the dive bombers for distributive property, with the exception of problem D. With problem D, you just have to combine the like terms. So I'm going to move on. If you want me to work out any of these problems, just stay behind in a Google Meet or ask me in class when you're here, and I'd be happy to work these out for you. Burgers Arama is the best hamburger place in town. The owner, Ms. Ham, buys two 5-pound packages of meat for $27.50. Use proportional reasoning to determine the information below. Be sure to explain your answer and organize your reasoning. So this is a little bit tricky because it looks like 5-pound packages cost $27.50, but it's 2 of them. So really, it's 10 pounds for $27.50, which by the time you divide the top and the bottom by 10, you'll realize this means that every pound is $2.75, right? That's the unit rate. So we can use that to solve our problem. So if you're going to buy 25 pounds, you're going to multiply 25 times $2.75. If you buy $55 worth of hamburger, then divide that by $2.75 to give you the number of pounds. And here are our answers. Problem A, it'll cost $68.75 for 25 pounds of hamburger. And for part B, you're going to get 20 pounds of hamburger if you spent $55. And that does it for our homework. So let's head over to our lesson. All right, good job. Take care. Bye.
Hey, feeling good, like I should. When in dark, walk around the neighborhood.